Hello everyone, I'm Janki Barot, Assistant Professor of Computer Engineering Department and Aditya Silverok Institute of Technology. Today I'm going to explain concurrency concept of operating system. So first of all, we'll discuss about today's agenda, what we are going to discuss in this lecture. Okay. So these are the terms we are going to explain today. Concurrency, then race condition, then what is critical section and critical section problem, and at last we'll see what is mutual exclusion. So let us start with concurrency. Now we'll start with concurrent program. First of all, that I have a question that what is concurrent? Concurrent means happening at the same time. So when two or more program will happen at the same time, it may told that it is a concurrent program. Or when two or more process will happen at the same time, it may told that it is a concurrent process, right? So it is a program that has multiple thread or a task of control, allowing it perform multiple computation in a parallel mode, right? And to control multiple external activities that occurs at the same time. I'm again reading that it is a program that has multiple threads or a task of control, allowing it perform multiple computation and in parallel mode, and to control multiple external activities that occurs at the same time. So logically we can see that concurrency is simultaneous process, right? It does not require multiple processing elements, right? And it requires the interleaved execution on a single processing elements. Now we'll see the problems and concurrency, which are the problems we are facing in the concurrency, right? So first here we have written that sharing the global resource. If two or more process want to share same resource, they can share that, right? Let's have an example that we have a network printer which is connected among 10 systems, right? It may possible that from 3 or 4 systems we can give print command, right? Print command to print out any document at the same timestamp. So all the systems are sharing the resource, right? So we can say that sharing global resource is the problem, right? Next is it is difficult for an operating system to manage allocation of resources optimally. Or it is obvious that operating system will manage how and when the which process will be executed first, right? So it is difficult for operating system to manage this. Now it is also difficult to locate programming errors. As a result, are not deterministic and reproducing. Let's see the main issues of the concurrency. First issue is non-atomic. First of all, we'll see that what is atomic and what is non-atomic. An atomic operation is one that runs completely independently of any other process or a thread. Matlab, it means that it is independent process or a thread, right? But when any process that is dependent on another process or a thread, it will call as non-atomic process, right? Now it is obvious that two or more process is creating or having a having a command at the same timestamp to occupy same resource, right? And it is also dependent, so it may create a problem. It may interrupt to another process also, right? So operations that are non-atomic but interruptible by multiple process can cause problems, right? The next term is race condition. Race condition is a behavior which occurs in a software applications where the output is dependent on the timing or a sequence of other uncontrollable events. Race condition also occurs in a software which supports multi-threading, use a distributed environment, or are interdependent on shared resources. Rest condition we'll see in depth in the next slides. Next is blocking. Here blocking is just do wait, right? A process that is blocked is one that is waiting for some event, such as a resource becoming available or a completion of IO operation, right? Another one is starvation. Starvation means what? A problem encountered in a concurrent computing where a process is wait a minute. Where we were in starvation, yes. Problem encountered in a concurrent computing where a process is perceptually denied necessary resources to process its work. Starvation may be caused by error in a scheduling or mutual exclusion algorithm, but can also be caused by resource leaks, right? Another one is a deadlock. Deadlock means it is a state in which each member of a group will wait for another member, right? And starvation will, in simple terms, we can say that starvation will be caused by error in a scheduling or a mutual exclusion algorithm, right? It is encountered in a concurrent computing where a process is perceptually denied necessary resource to process its work. It will wait for infinite time, right? It will wait for infinite time. It will wait for resource up to infinite time, right? So these are the main issues of the concurrency. Now we'll see race condition. Now what is race condition? When more than one process, when more than one process is executing the same code, one or more than one process is executing the same code, accessing the same memory segment or a shared variable, there is a possibility that the output or the value of the shared variable is incorrect, which means it occurs when multiple process or a thread read and write data items. The final result will depend on the order of execution. Now, what is race condition? Now we'll see this example, right? Here it has been explained that a race condition. In this race condition, there are two process A and process B, right? So we can say that when more than one process is executing at the same code, right? They are executing the same code or accessing the same memory segment, which is shown here, right? In a spooler, abc.pdf, proc.c and as2.txt. This three file is already occupied the slot, right? But when process A and process B were created and would be given the command at the same timestamp, they have found that which is the free slot for the execution in a memory, right? So what they does, both the process find out that seventh position slot, right? This address will having a free slot. So both will try to occupy this slot, right? This is called race condition. Both the process will try to occupy same memory segment, that is called race condition. That may possible there are many processes running parallel, but in race condition only A and B is considering, right? It may possible that A, B, C, D, many processes are executing and occupying the different slots, memory segments, right? But when same segment, same resource, same variable will be trying to access by this process, either it will be 2, either it will be 3, either it will be 4, then and then only you can tell that these processes which are trying to access a single or a common or a shared resource or a shared variable having race condition. Okay. So if A, B, C and D, four process will try to occupy this segment or this slot or any common variable, then we can say that process A, process B, process C and process D are in a race condition. Clear? Okay. So Now you can understand that when more than one process is executing the same code, accessing the same memory segment or a shared variable, there is a possibility that the output or the value of the shared variable is incorrect. It, it occurs when a multiple process or a thread read and write data items. The final result will depends on the order of the execution. What does it mean? When, okay, if process A comes before process B, right? And it will occupy 7, 7 slot. Wait a minute. Let's say here process A already occupied this. When both the process generated, they both find that 7th segment memory is this slot is free, right? So they have a command that in 7 you can go and execute, right? Now as soon as process A comes, right, A will occupy the slot, but process B won't identify that 7 segment is this segment is already occupied by A. So what this process will do? It will also occupy the same segment, right? Now what will happen? A will be override by B. So two, either of one will be executed, right? It's like musical chair. You can sit only, you can occupy, chairs will can be occupied by only one person, right? Like this, if A will come first, so and B will come later on, then A's data will be overwritten by B, right? Same if B comes first and A will come later on, and same segment, same resource will be occupied by two processes, then the last arrived or a last occupied process will be executed. Clear? So we weren't able to identify that which operating system weren't able to give any notice or any error for A, right? So earlier here it is written that difficult to locate programming error as a result, right? And are not deterministics and reproducible, right? So I hope all of you know, all of you are clear about race condition. When two or more process or a thread try to occupy same shared resource or a variable, right? Possible that the output or the value of the shared variable is incorrect, and the final result depends on the order of execution, right? Whether A will be first, then B will be override by A will be override by B process, right? So it is totally depends on the order of the execution. Now, what is critical section? Critical section is a section of a code where the process is performing operations that must be atomic. where the operation must be performed as a unit without interruption, right? So we find out that many processes are there have and they are in a race condition. So we need to find out the solution, right? We need to find out the solution. Its solution is mutual exclusion, right? So what we find out that let have some conditions and prepare the type of area or a section or a restriction that only one process can be executed and they in that particular area, right? So what here written that a critical section is a section of a code where the process is performing operations that must be atomic. Atomic matlab where the operations must be performed as a unit without interruption, right? A and B both are in a rest condition, right? These both are in a race condition. Now, if this area is a critical section, then it is having a condition that only one process can be executed at that same time, right? Though they are concurrent process, right? Though they are concurrent process or a concurrent thread, they have been given a command at the same timestamp. Still, either of one would be allowed at a time for a execution. This is the best solution, right? So, which are the criteria to implement critical section? Okay, I'll give the simple example of the critical section, right? After this criteria, first criteria is no two process can be inside a critical section at once, right? No two processes can be inside a critical section at once. At a time, only one process will be allowed. No assumptions can be made about speed or number of process, right? If more process are there and so we can't allow any process based on its speed up, right? Based on its task speed. No process outside critical section can block another process, right? So there must be wait, there must be queue. No any other process can be blocked by another process, right? So no process should wait forever to enter a critical section. What does it mean? That starvation will not allow, right? This means the process will wait forever, right? Forever, for infinite time, right? So I will have a proper or a common example. We can say that critical section, we can relate it with the ATM, right? In ATM, it is allowed for only one person at a time. An ATM, only one person will go inside ATM, perform that task, and after completion that task, it will come outside and another process or another person will enter in the ATM, right? So we can relate it to critical section. Okay, right. So we have already seen that which are the criterias we have decided to implement the critical section. Okay. Now we'll see critical section problem. There are many problems. Which is the biggest one? If more than n numbers of process are there and they are trying to access the same variable, shared variable, or a same shared resource, right? So what to do? What we need to do? From n process, we will allow only one process to execute to access that resource. And for another n minus 1 process, we need to put them in a wait mode, in a queue, right? In a hold, on a hold, right? So, critical section problem. Consider the system of n processes, which are P0, P1 up to Pn minus 1, right? Each process has a critical section segment of code, right? Now, process may be changing common variable, updating a table, writing a file, right? When one process in a critical section, no other may be in its critical section. Critical section problem is to design protocol to solve this. Obviously, we are trying to solve the concurrent race condition, and due to concurrent process concurrency, we are facing the race condition problem, and we have decided that that should be the critical section, right, where we can allow only one process to access any common variable or update the table or writing a particular file, right? And other process need to wait or need to hold for completion of the previous process. Okay. Each process must ask the permission to enter in a critical section, right? Earlier we have seen that process A will, if first process A will first come here and occupy this memory segment, but process B also having command that they need to go to this segment and execute that, right? So what will happen? Process A will be override by process B. So here what they have written, that each process must ask the permission to enter critical section, right, in a entry section. So what if when B will come, right? So B need to ask that whether I need to come in a critical section or not, right? So if A will allow, if A will give the consent that yes, I have completed the task and now you can enter in a critical section, right? So likewise you can have the solution of this critical section problem, right? So each problem must ask the permission to enter critical section and an entry section, and may follow critical section with exit section, and then remainder section will be there. Now you will be little confused that what is entry section, what is exit section, what is actually critical section. Critical section is, there is no such a space where all process will go there and execute, right? It is just a common code which can be accessed by a different process, right? This is general algorithm We can say that this is a general algorithm of a critical section problem, right? Here, general structure of a process PI, right? PI, then do while turn I is equal J, right? J, you can check that what is the value of a J, right? This is first entry section. If entry section will allow the enter the critical section, let's say that J's value, first of all, when process A will be come, then J's value is 0, right? So we can say that if it is 0, then it will enter to the critical section, right? As soon as the main code, will be executed by uh, process A, right? It will go outside the critical section. How? It will turn that J's value to 1, right? It will change the value of a J variable. So what will happen? It will automatically exit the critical section and will give the sign to another process that now you can enter. It will automatically change the value, right? when when process A will come, it will check that while turn equal J, here J's value is 0, then what will happen? It will automatically enter in a critical section and will be executed. And after that, when when the code will be executed and will come to turn equal J, right? What will happen? It will give this sign. It will turn the value to 0 to 1. So what will happen? Here automatically value of J will be changed and it will give the sign to another process, that is process B, that now you can enter to the critical section. Okay. Okay. Now, solution to critical section problems, right? So there are some solutions which is find out for the critical section problem. First one is mutual exclusion. If process PI is executing in its critical section, if process PI is executing in its critical section, then no other process can be executed in their critical section. This is called mutual exclusion. What is mutual exclusion? If any process 1 is executing in its critical section, no other process will be executed in their critical section, which is called mutual exclusion. Second one is progress. If no process is executing in its critical section, there exists some process that they wish to enter their critical section. Then the selection of the process that will enter critical section next cannot be postponed indefinitely. What does it mean? Progress must be there. If you have three processes, P1, P2 and P3, first P1 will enter, right? And it will be executed and will come outside. So it will through entry section, P2 must know that now it's turn to enter the critical section. This is called progress and it should be happen to solve this problem, right? So if you have a three process, that is a P1, P2 and P3, right? If you have a three process P1, P2 and P3, okay? So when P1 will enter in a critical section, right? P1 will enter in a critical section and complete its execution. It need to change the J's value so that next P2 process will give the signal that now it's turn to execute for P2. Now it's turn to enter in a critical section. This is called progress. After P2, there must be, it must be repeat for P3 also, right? So first one is mutual exclusion. It is obvious that if P1 is executing in its critical section, no other process can be executed, right? They have mutually decided that you go first and utilize the shed variable and after that I will go there, right? Progress. In progress, there must be continuity, right? There should not happen that only one process will go, will execute and come outside, right? So progress must be there. The third one is bounded wait. Now a bound must exist on the number of times that other processes are allowed to enter their critical sections after a process has made a request to enter its critical section and before that request is granted. Assume that each process executes as a non-zero speed, no assumption concerning relative speed of the end process. What does it mean? There must be a bounded wait, right? No starvation will be allowed, right? For a particular time, next process will wait and when here they have talked about the exit section, right? They have talked about the exit section. Through exit section, it is obvious that J's value will be changed and it will reflect to here, right? If there is no exit section, what will happen? All the process which are waiting to enter the critical section or which are waiting to execute, right? They all will wait for infinite time, forever, right? So here we can have the example, we can relate this problem to printer, right? I've already given the example that your system is connected to a network printer, right? And all system want to give the print, right? So what will happen? All 10 process will try to occupy at the same time stamp. It will try to occupy the resource, right? But it won't happen that how only one print will be as the output, only one print will be done, right? So what will happen for another? They will wait for resource to allocate, right? They will wait for the resource, right? Same as we can say that uh, if we are working on a Google Sheet, right? And if both the person will access the same cell, right? Same cell. Then if first person will write and will leave that critical section, will leave that cell, then and only then the second person can see what he or she had written, right? During writing any word or any document for uh, in a particular cell, another person won't able to see the data, right? Okay, now we'll see mutual exclusion in a critical section, right? So how mutual exclusion will work in a critical section? We have a process A and process B, right? A enters in a critical region, right? When at a T1 time, A comes into critical region, right? At a T2 time, B process will arrive to enter the critical region. But A is already in a critical region. B attempt to enter here in a critical region. B will be blocked. It need to wait up to process A execution time, right? Let's say process A will be executed till T3. As soon as it will be completed, A will leave the critical region, right? And at that time, process B will be entered in a critical region, right? And after completion of process B, it will also leave the critical region so that it can be occupied by another process also, right? So again I want to go with the agenda or outline of today's lecture, that what we have completed, that what is concurrency. Let's see the quick revision. Concurrent program or a concurrent process that are two or more process which will be happen or which will be created at the same time for doing the same task, right? Now problem in concurrency, obvious, they are they are able to share global resource, right? Operating system, it is difficult for operating system to manage the allocation of the resources, and obvious it is difficult to locate the errors, programming errors. Now, which are the issues of the concurrency? Now you are able to understand that which are the issues, right? Non-atomic. What is non-atomic? Atomic means it is totally independent process. But atomic operation, okay? But here non-atomic operation means it is dependent process. Now it is due to it is dependent process, it is obvious that it may interrupt to the multiple processes and will cause the problems. Now what is a race condition? That I have already explained, that when one or more process will try to access the same resource or a same code or a same memory segment, what will happen? They will have the race condition. That situation, that behavior is called the race condition, right? A problem encountered, sorry, race condition is a behavior which occurs in a software application where the output is dependent on the time or a sequence of the uncontrollable events. Now you're able to understand that what is race condition, right? Blocking. Blocking means you need to block another event up till previous one will be completed, right? So what is block? You need to wait for the event or for the resource which you want to access. Okay. Now, starvation. Starvation means it should not happen that blocked process will wait forever, right? They won't be able to access any resources, right? They won't be able to access any resources for infinite time. Okay? Deadlock. Obvious, it is a state in which each process will wait for each other, right? This is called the deadlock, right? Race condition, we have seen that process A and process B are in a race condition, right? But critical section, to solve this problem, we have identified that we need to, this process need to mutually decide that which process will go and execute and which process need to wait. For that, we have created the rules, right? We have created the criteria that no two process can be entered in a critical section. Only one process can be executed, right? After that, what is critical section problem? Though we have created the critical section, still we are facing many problems, right? Still we are facing many problems. We have decided that let one process do execute and complete their task, and after that another process will be entered. But what will be the situation? How much time another process need to wait? That we need to decide, right? So for that, this is the algorithm, that there must be entry section which indicate that, which need to ask that yes, you can enter in a section, and as soon as it will complete the task, it is solely responsibility of a previous process to change this, to execute this, so that they can give the signal to entry section. Okay.
Mhm.
So mutual exclusion is both the process will mutually decide progress. Progress means what will happen through entry section, right? You can say that through entry section, another process must be entered, right? And in a bounded wait means starvation situation won't be allowed, right? Which means it should not happen that forever some process will be blocked forever. The next is mutual exclusion with the criteria section, which is already explained, right? Thank you.